We're here in Redding, California, again, 3D printing this house. Emergent 3D has this project with their Cobod printer. They've got the batch plant mixer set up, and right now they're actually printing the third layer of the day. But here you can see where they printed up to 8 feet behind me yesterday. And yeah, they made great progress. They've got a screed on their system. We'll look at the 3 homes that they already printed, see their print in action today, and we're live. So you guys are gonna get to see it all raw in its truest form as it prints out right in front of you. So right now, everything's going great. They're running a little bit more of a wet mix than they were the other day, which helps them to have a stronger bond and better corners. It does have a slightly increased risk of collapse, but these guys are really well trained and everything's going smooth so far. So far, so good. And they're working on the inner sections right now, which connects the inner and outer wall. Those all go down first, and then the printer goes around and does the inner and outer layers. This section in the center is a prefabricated experiment, and then the printer is able to start, stop, to jump around to all these different portions over here. Then on this side, they have yesterday's print, which was full height. 2 days ago, they did from the lighter section up until right under the burlap, and everything over the burlap is from yesterday. Over here, it's 8 feet tall, and even though they're still printing, they've already got some of the electrical rough in. You could see the electrician was able to come in before they got the walls to full height. So it's a little easier doing the electrical at that stage than after they finish the printing. And they've got, you could see some leftover horizontal reinforcement that goes in every 12 layers or so. And this burlap is just increasing the humidity of the building and the printed concrete, helping it cure better. Now we get a look at the printer extruding, everything going well. You got Sean at the extrude head watching closely, communicating with Cassie at the operator booth. Let me know if you guys have any questions for Sean or anybody on the site. Huge shout out to Emergent 3D. It takes some massive cojones to let a YouTuber film a construction site live. So they're really awesome for being out here. Not every 3D printed construction team is confident or competent enough to let people on the site and let people see what they're doing like this. It's really hard to be innovating on the cutting edge when you're trying new stuff. Any engineer will tell you engineering's tough. You try something new, it doesn't always work the first time. So to do this process openly shows a lot of confidence and credibility. And these guys are smooth operators. Stuff comes up, but they know how to deal with it. And you might not even notice they fix some of this stuff that happens so quickly. There's some predictable things, like if they have to hit an emergency stop, then sometimes the Z axis will become miscalibrated, but they've become very efficient at recalibrating the system and fixing all these little things that ultimately will be ironed out with more mature developments of the system. For now, they're fixing these things by hand and adapting to everything that comes up on the job site. And this is a union job in California with the Liuna Labor Union. They're doing a great job of adapting technology and automation into the workforce. Much better than you see the writers' unions in California complaining about ChatGPT. The blue-collar unions are embracing the future and technology and really ready to solve the problems that technology offers to help with. Really appreciate everyone watching the video. If you guys could hit that like button, it'll bring even more attention to construction automation and push out this live. Every time someone hits the like button, it shows 10 new people the video. How much training is necessary to do this? Usually when a company buys a printer, the group that sells them the printer will help them with the first project, to make sure everything goes smooth. And typically that's about enough training for them to go off and start printing a second house, third house on their own. It's certainly challenging once the training team leaves for the first one, but this crew, Emergent, is on their 7th home. So they've become really efficient with the system, and they're printing the same floor plan over and over. So they've become accustomed with what to expect and even made some adaptations, improvements along the way. But you can expect at least 2 weeks of training, maybe 4. Some companies will do the training before you get the printer in a facility. You'll travel to wherever they manufacture it. Other groups will send their team out to you. That's a really important question, though. You definitely want training, and training can be a good way to get experience with a system before you have to pull the trigger. In a minute, you'll see the system stop, and it's able to pause the flow of the concrete before it moves to the next location. On the side right there, you can see the screed, and that's how they're getting this flat finish, which is really nice. On some other printers, you see they have really convoluted layer lines, which is sticking out the sides, and sometimes it's a nice aesthetic, other times it looks sloppy. With this flat finish, it's easy for them to apply paint, stucco, other types of finishes. We can take a look at the other 3 finished homes they have on this site as well. This setup, the printer they have with the batch plant mixer, everything runs at about $1 million, everything included. So it's certainly expensive to get started, but in the world of construction equipment, pretty standard compared to a crane or a big excavator. And if you're curious about the batch plant mixer, that's that big setup over there. You've got the mixing system. You've got big silos containing your gravel, your sand, cement. And this batch plant mixer enables them to use larger size aggregate, which reduces the cost of your material. They got Tim up there. Tim's a material mixing legend, and he started off doing curing at the Emergent job site. You saw him last year, and now he's operating the batch plant mixer. Pretty technical job. A lot happens, and you have to be able to adapt and change quickly. You have to wait for the material to get all the way through the hose for the changes to be reflected. And so Tim has to be on point with the computer system here, adjusting everything, communicating with this team to enable a smooth print day. They're running at about a 15-minute layer time, so each layer is 15 minutes. That one was about an 8-minute layer time, and so they got to full height in 3 days of printing. They'll do this full height in about 3 days of printing as well. So day 1, they got up to that knee height level on this side. Day 2, knee height on the other side. Day 3, up until the section under the burlap. Day 4 was the section on the burlap, and now it's day 5 of printing. Ideally, they'll be able to finish this project off in 1 more day of printing after this. And then, of course, they have to do the roof and all the other finishings. It's not done yet, but they have rough-in plumbing through the slab. And as they're printing, the electrician comes by and installs the outlets. You can see the lower levels installed over there. It's easy for the electrician to reach down there before the print reaches full height. I don't think they have this in Colombia yet. Maybe you could be the first. I don't think they have enough stock to sell 50 at once. There's usually at least a 3 or 4 month lead time on these systems. They get produced in Europe and then shipped over. And shipping's been tough historically, so that lead time's been extended for a lot of teams. You got to remember this is still a blossoming industry, and so the equipment isn't really ubiquitous yet. It's not easy to find rentals, but it's growing very quickly. We're seeing more and more teams than ever before printing concrete all over the world. You can clearly see it's not removing humans from the job site. It's just changing the kind of work that people need to do. And the human inputs here are still very important. People are watching critical components, both at the mixing system and behind me, not on camera, at the operator booth. The people are the most important part of the job still. Now it's done with the middle sections. It'll go back to printing the inner and outer layers. If you guys want any specific shots, let me know. I can also give you a little walk through the 3 units that they've already completed. One of them has the girders in for the roof. You guys have any preference? You want us to keep watching the print or see the completed units? What's up, Qadim? All right, so you guys are watching Emergent print their 4th house in California, and this is a permitted construction project. Getting a permit for a 3D printed house is not an easy feat because it's a new technology. Even though they use traditional permitting and structural engineering methods by backfilling columns with rebar into the wall, it's still a leap of faith for a municipality to accept the new construction method, especially in a state like California where they have tremendous restrictions due to the earthquake and wildfires. So to pull this off is really a tremendous accomplishment for the Emergent team. You see a lot of 3D printed construction projects around the world completed in agricultural zones or places where you don't even need permitting. And so this is really a step in the right direction of making it reality. People promise things like faster, cheaper, all this stuff. It's only the people really doing it out here like Emergent that see the truth of automation. Some people will try to tell you just press a button and press go. That's not true for anybody. This is one of the most efficient operator teams you're going to see, and they're still out here paying attention, working a real job, and the people are a critical part of the process. every day they're learning new things, making subtle improvements. You make 5% improvement here, 10% improvement there, and it's happening very quickly all the time, way faster than they're improving stick-built construction or cinder blocks. That stuff's been around for so long, there's very little you can do to innovate, but this stuff is so new. Everybody has ideas and it's changing all the time. Thanks, Tim. I try to cover all the 3D printed construction progress happening around the world, and it's fun watching automation take its place in an industry that has historically been very traditional, not taking computers on site. But the robots are here, and it's pretty awesome. Appreciate that spelling, Tim. That's the first time my name's ever got spelled right in my life. No, I'm not in Colombia. This project is in Canada. Sorry, not Canada, California. I'm going to Canada next. We got someone representation from Kuwait. That's awesome. Where are you guys all from watching in the comments? Got an international crowd here. Alberta, Nidus. No, Nidus, they said they're not ready for me to stop by yet. Maybe they got a print starting soon, but I'll be visiting 20 Additive Manufacturing up in British Columbia. Hopefully, I think Nidus has some new projects. Since the last time I was there, they've done a 4-unit apartment complex, which is pretty cool, seeing the scale increase of the buildings, not just a 1-unit, a 4-unit. All kinds of awesome projects popping up. But there's a project with the labor union. It's the first labor union 3D printed construction job that I know of. We got people from Maui, Sweden. Awesome. Raymond Peters, the Quick Creek guy. The Pumice Creek, sorry. We got representation from Toronto, Canada. I haven't printed Adobe. This isn't my project. I'm just a YouTuber. I try to film as many 3D printed construction projects as I can, but I have filmed printed Adobe with emerging objects in Colorado. I filmed with them recently. I'll have a video coming out soon. People from Arizona. Arizona's got 3D printed construction too. It's a hot spot for it. How many members working? Hey Ram, they got right now five people, 6 people, but some management. So really, ideally they'd operate this system with 5 people. They could operate with 4 people. Yesterday they only had 4 people. We got people from North Carolina, Poland, cool, all over the world watching this print in Northern California. And huge shout out, of course, to Emergent 3D for their competency, their skill level. It is not easy to print concrete, and to do it live adds an even greater level of pressure that Emergent is handling fantastically. You can trust groups that are transparent and open. It's much harder to trust groups that won't print in front of you. If you want to contact me, you can reach out on the contact form of my website. You can go to automateconstruction.com or automate.construction and navigate to the contact form. Shoot me an email. Happy to answer questions about the technology. I've filmed different 3D printed construction companies all over the world. This print is being done by Emergent 3D. Very competent team operating a cobot printer with the Liuna Union. And they've got a batch plant mixer. So the batch plant mixer over there is enabling them to mix material on site. They use that forklift to load in the sand, the cement, the gravel, and they're also using a larger aggregate size, which enables them to use real concrete rather than the mortar that you usually see on 3D printed construction sites. And the difference between mortar and concrete is that aggregate size. When you have the bigger aggregate, you need less cement to bond everything together. The big aggregate is already solid like a rock. So having that big aggregate in there, some say even reduces cracking, certainly reduces your material cost. ultimately, when they collect enough data from the batch plant mixers, they'll be able to change the material mix throughout the day based on the ambient conditions like sunlight, temperature, humidity. Really appreciate all you guys watching at home. If you could hit that like button, it'll bring, for every new like, we get 10 new people in the live stream. So just by sitting at home watching, hitting that like button, you're helping to grow the construction automation community. It's been really awesome watching this industry take off. I remember the very first cobot print in the United States by Printed Farms in Florida. Found out about it, had to drive down there and watch the couple print days from a garage project they did. It was the very first permitted 3D printed construction project on a cobot printer in America. And even though it was an agricultural permit, still went through the permitting process. And since then, I know there's a bunch of these printers out there. Cobot has sold units in Florida, Canada. This one, they got one in a bunch of places. They've sold a bunch of units, and now 3D printed construction is happening all over the world. There used to be such limited projects. I would drive halfway across the country, sometimes 40 hours at once just to see a 3D printed home. And now there's so many projects I've gotten to see, 8 in the past month alone, 2 per week. This is my 3rd day visiting the Emergent print, and they're printing so quickly I had to stop by a few times. They're getting a whole house up in just 6 print days. They're able to get that side all the way up in 3 days, this side fully printed in 3 days. Of course, they still have the rest of the finishings, electrical, plumbing, roof, but some of that stuff is happening during the print. The electrician came in and did the wiring for the lower row of outlets. Yeah, it's interesting. Someone mentioned building a printer versus buying a printer. I've actually seen, I have a list of 102 different printer manufacturers available on the Automation Nation for members. And yeah, with 102 different printer manufacturers, it's very hard to say is someone the best, because they all have different things that they're best at and different statistics that they might be able to claim in terms of fastest, strongest, biggest, easiest setup, most mobile. Pretty much everybody can claim to be the best in one way or another. To decide which one is best for you, I would go with whichever company will be the most transparent and whoever you can have the best relationship with, because the technology is such a work in progress. Next year, they'll have all kinds of updates, and you'll need a good relationship with the company that you sold the printer to in order to get all those updates. You want to keep the warranty intact, and certainly anything they say they can do, you want to get guarantees or written in paper. It's been incredible watching. Cobot has improved this system over the years. They've been really putting a lot of time and effort into developing the system. And for example, this hose management system was a lot of iterations. And these things, they're constantly improving, reiterating. It's really a testament to engineering, and it's cutting edge stuff they're working on. Automating construction is no easy job. A lot of people said it couldn't be done. Here it is. Okay, what did I miss in the chat? Let's see. For this system, they're mixing the material on site, so I don't think Cobot has a 40% profit margin on this material. Cobot is shipping them just a small, like 1% additive that gets mixed in with their locally sourced gravel and concrete. So maybe they're getting a 40% margin on that little 1% of the mix, but it's such a small portion. With a batch plant mixer like they have here, the material cost is reduced. You do have a little bit extra labor potentially until it's automated. The cleaning takes at least a couple hours, and also the setup and takedown is 2 hours. So if you want to move from that house over there to this house over here, 2 days down, 2 days back up, most likely, and that's with a pretty well-trained team. Give you guys a close-up of the print over here. The sand doesn't run out because they have Tim over there keeping it full constantly, and also someone else with the forklift loading it up. With good communication, they don't run into problems like that. Unlike most prints, this actually is printed concrete. A lot of teams will use a mortar, which is supposedly weaker but easier to pump for some systems. These guys have a batch plant mixer, so it enables that full-size aggregate concrete. They also have a really tall layer height, which helps them extrude more material quicker.
Are you doing a live right now?
Yeah.
Hello, everybody.
We got Sean, the operator, over here.
Are you what live are you?
We're live on YouTube. We got
Nice.
26 people watching.
Nice.
But these 26 people are better than the 250,000 we had on TikTok.
Yeah, yes, higher quality. It's on YouTube live. Yeah, TikTok live. Yeah.
Yeah, that's right.
Tim, tell them when they're done with that. Tim, when they're done with that fucking.
The takedown cleanup process is usually like 1 or 2 hours. You put an orange sponge ball through the hose, power wash the extruder head, all the little pieces in there. And then you also have to give a thorough wash to the batch plant mixer. Basically anything that wet concrete touches needs to be thoroughly cleaned, or else it's going to harden and be much harder to chisel off later. I'll try to keep this live video running for the next couple hours if possible. So if you guys could give it a like, a share maybe, we'll try to get more people in here. Every time you guys like the video, it brings 10 new people into the live stream. So you're growing construction automation community with the click of a button.
Dr. Babak in the house.
People talk about hempcrete a lot. I've never seen hempcrete printed yet. Maybe someday. Babak, what do you think about hempcrete?
thinking about it.
Have you ever seen it printed?
No,
Not yet.
no. But I think we are capable of doing it.
Nice. It's a very common question.
Yeah, I think we can do it.
What's
Probably. We just need to find a source, someone who can supply us.
you have a new 3D printed part in your hands?
Yeah, this is some like a R&D prototype.
Cool. They're always working on R&D projects, trying to innovate new stuff. There you got Babak in the blue shirt, is their local materials expert. And it's really critical to have a materials expert on site. The material is a critical component. After the job is done, the printer leaves, the people leave, the mixer pump station's gone, the generator's gone, but the material should stay there for a lifetime. So getting that right is really an important step. This material is very different from traditional concrete because it needs to get all the way through this big long hose, not solidify in the hose and then become solid on the layer so that it can support each subsequent layer. It's a big challenge. The machine can control layer height. They have a tremendous amount of precision in their XYZ coordinates of the system. And these are some of the changes that they'll make. You see Sean over here communicating with the operator, and they'll be shouting out different numbers like football plays, trying to make sure they get every layer extruded with maximum strength, efficiency, trying to go as quickly as they can, still getting strong layers, good bonding. While they're doing these kind of boring middle sections, we can take a look at the batch plant mixer over here. And then they got a completed unit on this side. So you can see they got a bevel on the window there, some other customizations. The wall is really smooth, much flatter than some of the other systems we've seen because of that screed that they have. They don't really have cracking here. Some systems have tons of cracks, and I certainly don't see any top to bottom cracking. The system looks really good, and they printed this same floor plan like 7 times, so they're really getting good at it. Now they got the girders up on this section, so that's where the roof will be attached to the concrete wall. Roofing with concrete, even with cinder blocks, is not the easiest per se, but they got the girders on top of the poured columns so that you get some good structural integrity, and then you get the master bedroom side over here, and then 2 smaller bedrooms on this side, living area in the middle. And that's what every single one of their floor plans looks like. Then they take down the printer, move it to the next section, and get started again. If you guys have any questions or there's something you want to see, just let me know. The rebar wires off the shelf, they use a similar type of wire for cinder block. Of course, you want to get as much off the shelf as you can to reduce costs. Yeah, of course, there's vertical rebar, and those get tied into the slab or joined to the slab with, I think, a chemical bond. That way you have one solid structure all bonded together with tensile strength. All of the permitting is done with those vertical columns. So the printed concrete basically just acts as permanent formwork for the poured concrete and rebar in the interior. Oh, congratulations to your son. There's definitely printed concrete happening north of the border, and this union crew is actually helping to create educational platforms so that the rest of the union members will be able to learn how to use this technology and scale it around the globe. Having a big union like that is really helpful because they can train up the labor force and have reliable construction labor for this technology.
You're gonna be filling in right here. This column. Hit it real quick and put something there. So you keep doing that. I'm gonna do it. Where's that bucket? Oh, right there. Come on, yeah.
They're certainly adjusting for environmental changes, and this is a qualitative process. So Sean over there is watching the print, and if he sees something he doesn't like, he communicates that either to Cassie at the operator station or Tim at the mixer pump station, where they can make the appropriate adjustment and make sure they get a continuous quality flow. You guys are watching Emergent 3D print their 7th house. At this point, guys. We got Don Luke up in Toronto, Canada.
All right, Steve. Let's start putting the 5/8 in. The wall. Start right here, Steve. Yeah, let's jump on that. You guys run with that. Yeah, finish that section. So we got hardware going in the print, so look alive. I may pause and travel movement or something. Okay, Cassie? Chemical at 2.6. Getting hotter.
I think it looks great. You guys are smooth operators.
Best in the world.
It's hard to argue with.
So Babak said we're the best crew to when we had hoses clogging, everything was going to crap.
You guys laugh when you say it, but there's not a lot of crews out there, so.
Go good, they go good, but when they go bad, they go bad quick.
Certainly the best permitted house in California crew in the world.
Right.
No doubt.
Anybody printing in California?
You guys are the only ones with permitted construction projects in California.
No, we're the only ones in Cali. Drop it back down to 4-0. 4-0. Tim tell you to share the last one? Oh, he's checking it now. No, tell him to shoot for 20, 21. Good, dump it. Shoot for 20, 21.
Why does it do that lift up down?
It's in our software. Yeah. Because we're trimming these for rough openings to install windows and doors.
So it just gives a better finish that way?
Yeah, I mean, it's like a leftover from when we upgraded our software.
Ah.
Our AutoCAD. We could really, we need to put those in there to control the cobot slicer. It's kind of, it's kind of not advanced. So you need to put these little breaks in the wall so we can control where it starts and stops. Because I want to be able to say, well, today I'm going to print this one first, or tomorrow I can print that one first.
Mm-hmm.
For us to do that, we need to break up every object like that.
Yeah, that makes sense.
It's the way the slicer's built.
It's interesting you mentioned that, Major. They do a little more layer smush. You'll see at a certain point, they'll come around just with a glove and kind of brush off the excess from the edges. And this gives them a really nice finish.
I'm going to slip on those 5/8.
This isn't the first permitted home in the US. This is the first permitted home in California, which I'd say is the most difficult state to get permitting in. And it's also one of the most in need of housing, with the fires and the earthquakes and the homelessness in California as well. I read somewhere that California is spending over $100,000 per homeless person on their homeless programs, and it's still not helping. For you to get an idea of the difference, you can see with the freshly printed layers, there's some excess material on the edges like there. But once they finish the wall, like this they completed the other day, it's very smooth because they brush off the excess with their hand. That's almost totally flat. So it makes it a lot easier to do painting or stucco. Yeah, the mic was muted, guys. Sorry for that, but I was eating a donut, having a coffee. The on-site electrical requirements, they need 480 for the printer and also 240. I think the mixer pump system, the printer requires 480 and the mixer pump is 240, I think. We got Verity in the chat. Nice to see you. We got Made making miniature buildings. Good question about the electricity. They do have a generator on site. These guys haven't done multi-story yet. There are some multi-story prints. There's a regulation called AC 509, extremely restrictive, says you can't do any two-story buildings, no commercial building. But people have gotten past that. A lot of the regulations, they're not laws, they're just kind of recommendations. I think there's a lot of room for improvement on the regulations for 3DCP. Yeah, the electrician can get some of the work done while they're printing before it reaches full height, while things are still a little more accessible. I'll show you some of the rough-in plumbing from the print yesterday. They have this wall up to full height. The rough-in electrical, I mean, they got electrical boxes in here already, so that pretty much just needs an outlet. And yeah, maybe not the easiest for renovations, but getting it installed during the print, it's pretty easy. You just reach in there. And this middle section is an experiment they're doing, a wall for testing.
All right, I'll watch that one.
Try it over what you got to do.
Get the window ones in first. Not casting fair to pause, but good.
This is printed concrete, so it does have a high cement concentration, but it also has full-size aggregate, unlike a lot of the other mortar mixes. So that full-size aggregate reduces the cost a bit, enabled by the batch pump mixer. So the slab does need to be thicker because of the weight of the concrete. It's a very insightful question, PC. You know what you're talking about. Astounding how they got the mix to behave like this. Well, that's certainly a feat of engineering they've accomplished. They got a materials expert on site, Babak, and you've also got Sean watching the mix from the extruder head constantly, making play calls to the mixing station. At the mixing station, they can adjust things like the water or the accelerant. The operator can adjust the speed, and by pulling these levers, Sean can maintain a really high print quality. They're using a locally mixed add mixture with a proprietary 1% additive developed by, I think, CMEX with Cobod. A video with a company called Spacecrete that makes a similar additive. They say that they're the inventor of it, so we'll have that video coming out on the YouTube channel maybe next week. Make sure to like and subscribe. Subscribe to the channel, turn the notifications on so you get all the future updates of how construction automation is transforming. That's what we do on this channel. We follow along the innovations of construction as technology takes over construction sites around the globe. These guys have been printing concrete for an hour already without stop. There's usually at least one prescribed cleanup process in the middle of the day to get everything flushed out. If you print for too long straight, you can have clogging events. So they kind of anticipate this and prepare with the cleanup process, but that shouldn't be anytime soon, I don't think. Everything's going really smooth right now.
Sorry about the other side.
You got Evan installing the rebar.
Evan, when you get that ink, cure everything. Brush is on top of this layer.
The starting point is determined in the slicing pattern, so the G code, which determines the path of the printer. Yeah, it is. It's really quiet. You got the generator, you got the mixer pump system, but also the new microphone I have is much better than the old mics I was using, so you get a little bit of noise cancellation. But yeah, it is really quiet on site. Certainly no grinding or screeching like we've seen at some of the other projects. And here comes the electrician. Yeah, as you can see, as the print is going, the electrician is able to measure out the wires, get stuff installed. .3D printing should be much more popular. You know, it is getting more popular all the time. Yeah, it's definitely growing really fast. Just a couple years ago, the first homes were being printed. We filmed it on this channel, and now there's all kinds of projects all over the place. And we got Evan spraying the curing agent on the concrete.
Either way, we might have to delete a layer and the G code so the window's still high. There should be a note on that paper.
The goal is to make it cheaper and take less time. There's definitely a process of iteration to get there. This is a new technology, and so people are learning how to operate it and kind of ironing out all the details. And it's a lot of different technologies coming together. You got materials experts, software experts, hardware experts. A lot of really smart people in a bunch of different fields coming together to make this happen. If anyone ever tries to tell you they're an expert in 3D printed construction, that's crap. You can only be an expert in so much, so many things. I mean, you need an expert in materials, you need an expert in robotics, you need an expert in software, and nobody can really be all three unless you're maybe assembling a competent team is the most important skill for success in any construction project, but especially 3D printed construction. Now you see Sean installing the trusses, which were cut to size earlier. And this is pretty standard, like the horizontal reinforcement for block. You want some connection between the inner and outer layers, giving you tensile strength.
There you go. You want me to slow down? I'm going to slow down next layer.
You can see Evan expertly sinking the reinforcement into place where the next layer of concrete will go over and solidify it permanently. This is a collaboration of man and machine. Someday it'd be really cool to set these guys against a bricklaying team and see who can get the home up quicker. Now you're getting a live view of the outlet installation. They just cut out the wet concrete. They'll be able to slip the box right in there. And that's how you install electrical on a 3D printed home. If you guys are learning anything, make sure to give the video a like, help boost it in the algorithm a little bit. Every like you guys give the video, 10 new people will find out about the channel, and you guys will help grow the 3D printed construction community from home with a click of a button. Now we got the printer coming over here. It's got that great start-stop function. They have some plastic underneath this print because they don't want it bonding to the slab. It'll be sent out to the lab for testing after the print.
4-6. 4-6.
Give you guys a look at the extruder system and the hopper. They got a little view station up there. Back in the old days, it was very hard for the sensor to tell where the concrete was filled. So the operator would just be looking inside that peephole the whole time, telling the mixer pump station how much more material they need. But now it's automated. They got a great sensor in there, and as long as they wash it out and keep it clean, it can tell how much material's in there. And there's also an auger mixing up the material inside so that it stays wet when they do the start, stops, the pauses. Really dynamic system. Also able to rotate on a U-axis at the extruder.
That's the second time I heard the bearing hit that.
What do you guys do every 3-hour cleaning or 4 hours?
3, 4. Depends on where the pump is. Right here, the mixer.
If my phone battery lasts long enough, we'll get to see a full cycle.
Yeah. I mean, we could do without it, but at the end of the day, it takes like an extra hour to chip everything out. It's way more productive to wash out. Maybe we can do the wash out in 10 minutes. I told you that. 10 minutes, make it happen. NASCAR big crew.
That's Elon style, set some impossible time limits.
What's that?
That's like Elon Musk style. If it takes 10 minutes, they got to do it in 3.
Yeah, exactly.
He's hard to work with, apparently.
Check. Grab one from the different window.
Inside the Z box. When you say the Z box, you mean one of those guys? Each column has I guess a box to be able to lift the Z axis, which is up and down. I don't know how I could show you inside of that box though, like a latch, unlatch it. I don't think Cobot would like that. We'll leave the inside of the Z-Box a secret for now. But it's just a stepper motor in there, I think. Scaled up a bit. It's surprisingly similar to a regular desktop 3D printer. You get the X-axis, Y-axis, Z-axis. They get usually it's a step file instead of an STL file. But after they get that step file, they convert it into a G-code path. And from the G-code, they get basically a map for the printer to go from step to step, every point it has to hit. They can definitely add pigment, change the colors, a lot of control there. It's a good question how much the house will cost. They're probably for sale. I'll try to post a link to the MLS listing if they're selling it that way on the open market. You can see in the back they got the forklift loading the super sacks into the batch plant mixer, which is enabling them to mix material with local ingredients sourced in California. They got the sand, the gravel, the cement. All right, we're back in the chat. Let's see, the target slump. Ideally, they have no slump, but obviously that's not really possible. The cost of the house is TBD. If you guys have any questions, feel free to throw them in the chat. I can give you a closer look at anything if you're looking for it. He's got maybe 20 or 30% left.
So 1.224. Let's go additive to 1.4. 1.4 on the additive.
Is that 42 on that extreme? Bump it up.
It's the electrician carefully lining the wire for the lower row of outlets into the wall between the inner and outer layers. A section which will later be filled with loose fill insulation. Back to the middle section.
What's the next call out, guys? Additive 1.6. Additive 1.6.
Wow, we got a donation from Major. Never got that before. Thanks, man.
1.8.
I'll keep this live stream running till I run out of battery. And then I'll charge up and come back. If you guys have any questions, let me know. Try to ask an operator or somebody on site. They got the materials expert, Babak in the blue shirt. You got operator Sean in the yellow shirt. Each layer is running about a 15-minute layer time, and the entire house gets printed in 6 print days, half on one side, half on the other side. They have 5 people operating the printer, and then Babak in the blue is supervising, so you'd say a crew of 6, and then the electrician is here today as well, but not required for the print. It's just really efficient to get everything installed at the same time. So you're getting the electrical rough-in for the lower rung of outlets installed while the print is going on. Really high level of efficiency here. That's how they're maximizing the time on site. In construction, time is money. If they can get the home done a month earlier, that's an extra month of rent. Do you have a target slump?
Keep it around 6 inches.
Around a 6-inch target slump. You always want to reduce the slump if possible, but zero slump concrete wouldn't flow through a hose very well. That was a question from Quadim Stewart in Toronto.
Is it live?
Yeah. Live on YouTube. We got the mic live too.
Hey, Baba, can you go
talk to Cassie for a second? About.
Hey, Stephen. Steven. Huge shout out to all the supporters in the live. Huge shout out to Sean, legendary print operator. Boom, baby! Printing his 7th house. Few people have that much experience operating a concrete printer. Now we get Sean multitasking with the curing. Sean joined this company specifically to work with concrete printers, believes in the future of automation and construction. How often do you spray the curing agent?
It varies. I think Babak likes us to do it about every like 6 to 9 layers, with temperature varying. A day like today, I'll spray it on schedule. Other days we cancel it.
The curing agent, I just asked Sean, it's one of the levers that they can pull to get better control over the curing speed of the concrete. So depending on the weather, the ambient conditions, they may use more or less. But typically every 6 to 9 layers would be a regular interval for the curing agent. If you go too much curing agent, you can end up staining the material a little bit like we saw on the first house, but it'll get painted over and no problem.
So 2 layers, we're going to do Dayton's, okay, Evan?
Because they work for a labor union, they're getting paid the exact same rate as regular labor. A lot of other 3D printed construction sites will find really cheap labor because people are excited to work with the technology, but in California, you use unions, and they're also getting an added educational benefit from the union who's documenting the process, so they'll be able to train future laborers to work with this technology. This is the first permitted 3D printed construction team in California, and so they really didn't have anyone to show them how to do it. They had to figure everything out on their own. And now that they've kind of crossed that barrier, they're ready to scale up production. Now on their 7th home.
Are they in there? Are they in the next sleeve? Tell them I gave it to him last Friday when I was in the office.
Funny you say that, Quadim. I actually do have a course on 3D printed construction, a 4-hour video series condensed as densely as possible to teach you everything I've learned from visiting as many printed construction sites around the world as possible. In the future, I hope to offer some in-person training opportunities, but for now we have the digital course, which will be a prerequisite for the in-person training in the future. And that's in the beta still, so I'm working on adding quizzes and a certification, but while it's still in the beta, you can get it over 50% off at automate.construction or automateconstruction.com. And you'll have access for life. Oh, that's why I recognize your name, Quadine. You did the course already. That means you'll be the first to receive an email when in-person training is available. It might be a while, but it's going to be great to get people together. There's no replacement for hands-on learning experience, especially with a material like this. You got to see it, touch it, to understand when it's qualitatively ready to print. Oh, Claudine, you were an OG course member, so you saw the course that I drew on a piece of paper duct taped to the wall of a motel over a year ago, the first original version of the course, and then I reshot the whole thing in a more professional studio, in a collared shirt, looking a little professional. And yeah, I'm really happy with where the course is at now. I added a physics section, and so you can get an understanding for a lot of the material science and physics equations that people use to determine when the material is ready, how high they can print. A lot of smart scientists have put in work to developing this stuff, and it was important to me to add the physics section because this is really a work in progress, and it'll be people who understand the physics and material science well that innovate and adapt, bring the technology where it needs to be. But of course, in-person training is the most important, so I'd really like to add that.
Check everyone. Maybe a 40, half hour, 2 hours, you have to leave with more material.
The diamond age process is different because they use kind of a bigger square, but it is most similar maybe to this system because they are using a taller layer segment. Other cobot systems use either a round extruder's head or continuous layers. The start-stop is something that this system has in common, I guess, with diamond age. Yeah, it's really been incredible watching this industry transform over just a couple of years. I mean, my first videos from WinSun in China were almost 4 years ago now, in 2019, and they had a huge facility there. Now, America's really taken over the reins of innovating this technology. There's more projects happening in America than anywhere else in the world for 3D printed construction. It was Europe maybe in 2021, and Dubai in 2020, they had a big initiative. And then 2022 and 2023, America has really been taking the cake of the 3D printed construction projects in terms of the houses. This is a Danish company that makes this printer Cobot. They've done a lot of printer sales around the world. There's over 100 different companies manufacturing printers, so it's been cool to see how they all have been evolving, improving. And you're watching the construction innovation unfold here at Automate Construction. We got people joining from Turkey. Do you guys have 3D printed construction in Turkey yet? I bet you will soon. This technology is exploding all over the world. Representation from Oman. Oman's got one of these systems at the German university. You can see they're on layer 10 or 11.
What height does men height?
And we are an hour and a half into this print. It's been going off without a hitch. Usually around the 3 or 4 hour mark, they'll do a cleaning process. So they've already gotten about a foot up in 90 minutes, and hopefully they'll get another few feet up today. This machine with the mixer pump system you see back there, the batchment mixer, all in, it's about $1 million, give or take. And maybe 3/4 of that's the printer itself, and then quarter that's the batch plant mixing system, which allows them to mix with local materials, reducing the material cost. Before they were spraying a curing agent, now they're spraying some water. Increases the humidity, decreases the curing rate, and increases the strength.
Come over way, Steve. Let's go. Yeah, don't go any higher in RO than that. Yeah, you want to check one again? Because the travel moves, we need to wait one more. I'm probably going to slow down on that layer, so. And then check one Dayton rod, and that one right here. One of those two. You might just do the washout like you guys do the Dayton. That'll probably be the best. Washout. As soon as, I mean, you do it a little earlier today, that's fine. You do an hour or two. That's buried, flange to flange. That's all the way down. One more layer? Yeah, one more.
They definitely use an additive. So with that batch plant mixture they have back there, it uses about 99, 98% local materials in terms of gravel, sand, cement. Then they have a small additive that they put in. I believe it's a 2K system so that the material can flow through the hose, and then with the small white nozzle or hose they have, just a tiny little hose, it's not a lot of material. They put in that liquid accelerant for the last step, which gets mixed in at the extruder with an auger that's at the thick part of that blue section, and that starts the setting process of the material. You need a phase change so that after the material goes through the hose, once it's out of the extruder head, it starts to solidify very quickly. But if it starts to solidify before that, you end up with a clogging event, which is detrimental to your process and efficiency throughout the day. If you have a clogging event, you have to stop the whole thing, empty out whatever material is left in the hose, get water flowing through it, get rid of all the extra sediment, and start over from scratch. So avoid that if possible. Simple cleaning at regular intervals. My phone is probably going to die before the first cleaning event, which would usually be at around 4 hours. They've been printing for almost 100 minutes now, making really strong progress. They'll have this whole house printed to height in 6 days of printing. 3 days on each side, and this is the bigger half, this whole side, taking about 15 minutes per layer, whereas the section behind me standing in took about 8 minutes per layer. Managing layer time is critical for making sure each layer can support the next one. If you have too quick of a layer time, then you don't have enough curing time for the material to become solid from the reaction that happens with the 2K additive. And if you go too long, have too much time between layers, then it'll fully cure and you won't to have a bond. You need it to be somewhat liquid still to maintain the bond of the last layer to the freshly printed new layer. When they start a fresh day on top of the old concrete, which you can clearly see is the lighter gray color, they use that glue down here, and that glue, a thin layer of it around the whole top section, will ensure that you get a nice bond between the old material and the new material.
We can't have that because then we have the layer fall. Next layer to print.
We're watching Emergent 3D in Redding, California, print a permitted house in one of the most difficult states to get construction permits just for traditional construction. With all the earthquakes and the fires, this team, Emergent 3D, managed to get permits for this new construction method 3D printed concrete. Now we got Evan putting in the rebar, which gets tied into the slab. All of the structural calculations are done with traditional methods, so the printed concrete will act as a formwork, giving space for to pour in columns. And when you have that poured column with rebar on the inside, that's just a traditional vertical load column. I just overheard that any minute now they're going to do a pause, and we'll get to see the clean out process.
Let's do one more layer. One more layer, and then we're going to do Dayton. We're going to do a washout when you guys do Dayton, okay? Do that, Evan? We're going to do one more layer on top of that. We're going to do Jackson, we're going to do one more on top.
So they just said they're going to do one more layer, and then they're going to do a clean out and a Dayton process, Dayton install. I don't know what a Dayton is. I'll have to learn something new today. Hey, Sean, what's a Dayton? Oh, okay. All right, so the Dayton is the rebar we were just talking about. Evan's getting screwed into the slab. That way you have a nice, strong structure with consistent tensile strength.
Use it up by two. Want me to clear it now, though? Yeah, clear it down. Clear this whole inside after the printer.
No, they're not doing 100% solid backfill in the wall. They only backfill the sections with the poured vertical columns. The rest of it just gets in blown in loose fill insulation. And it needs to be something blown in or something loose fill because the reinforcement between the inner and outer layer. So you can't just slip a foam block in there. You can use expanding foam. Wow, coffee on Mr. Lou Dog. You're the man. Really appreciate everybody watching. You guys make this possible for me to be able to film and travel around and cover the future of construction automation. We're watching an industry transform in front of us. And it's been a long time. Every other industry has seen the benefits of automation, robotic arms and manufacturing. Even some services are becoming automated. ChatGPT is automating white-collar jobs like writers. And we're here in California where the writers' unions are fighting off automation. They're on strike to prevent ChatGPT from taking their jobs. But you get the labor unions, and these blue-collar guys are out here working hard, accepting automation, embracing it, ready for the future. They're not afraid of robots on the job site. They're They're loving how it's changing the work. It's bringing young people to the job site, and it's changing the onus of the work from physical labor to working with your minds and problem solving, coming up with new innovative solutions. And I think that's what most young people want, is something that's an important issue. Everybody in the 3D printed construction industry is saving the world in terms of, you look at Maslow's hierarchy of needs, you need food, you need shelter. It's some of the most fundamental human needs. And if we can automate the way shelter's produced and have more people living in a higher standard of housing, I think that's the best thing humanity can achieve in the short term. And that's why construction automation is so important to me. Even though from our perspective it looks like everything is going really smooth, these guys are so experienced that they're able to tell little subtleties, and that signifies that it's time to do a cleaning process. So identifying this early allows them to have an easier cleaning process rather than waiting till the end of the day. It could take an extra hour or longer. Having preventative measures is kind of like the way you measure twice and cut once.
Hey Steve, add a little bit of material right here. Try to fix the complex problem a little bit. So Cassie, we're gonna watch out. We're gonna start at the top one. When we do the washout, we're gonna have you humped in, okay? Evan? He does it all. But I'm stuck with break all day. I was waiting for you to come in. But you can do the games if it's over. You know, like if we know the games, then we can call you. They get the real effect when it's like spray it.
Yeah.
Oh, well, you don't have in a Ziploc for that, I think.
Maybe when you have the water one out.
Come on. This is non-toxic, bro.
That's what they all say.
First date's gonna be right here. That could be that one. Yeah. Right there.
We learned a new word today, Dayton. This is the Dayton, which has a screw thread at the bottom there, so it gets screwed into another piece, which is at the slab, and having everything tied into the slab gives you one solid rebar structure, which is critical for the vertical load of the building. has horizontal reinforcement, but it's really just a formwork. So all of the structural calculations of the building are reliant on the poured concrete with rebar columns. People ask, how does it stand up with no rebar? Well, of course, that's not the case. It has rebar. They'll be pausing to install the Daytons, the rebar screwed in anytime soon. And during the pause, they'll take advantage of the time to clean out the system. Even though everything's going great, cleaning it will ensure that everything continues to go great as they continue this print throughout the day. This crew does 4 10-hour days a week, so they get here about at 6 a.m. and ideally they're printing by 8 a.m. So they do cleanup process, setup process, they go over dry layer tests, they do the best they can to make sure they'll have a good print day, because once the material starts flowing, you're on the clock, and that material can set in the hose, it can run out of material. You got to make sure the hopper's full, the mixer pump system's full. You got to really be on. These guys can't just take a smoke break. They're kind of running on the printer's time, so they have to really pay attention. Having a 5-person crew is helpful, reduces stress on site. Yesterday they were operating the same system with a 4-man crew. So it's possible to do that, add some extra jobs, adds a little extra stress. Here you can see with a 5-man crew, they're really comfortable, healthy blood pressures all around, and almost complete silence besides me blabbing around. You guys like the zoomed out look at the system where you see everything going on, or do you like when I stand closer, follow the print head? How do I follow so many of these projects in person? Well, this is my full-time job, just traveling around to 3D printed construction sites, and I believe in the future of construction automation, so I think that creating a library of the evolution of construction and how technology is transforming the job sites is going to be a very valuable thing in the future. And in the meantime, the ad revenue and course sales, especially the Automation Nation members, is enough to cover the motels, Airbnbs, travel expenses, and hopefully I'll be able to continue doing this for a long time. And the audiences keep growing. You guys are awesome. Keep supporting the channel and everything. I don't plan on stopping anytime soon. It's totally self-supported. I never accept money from 3D printing companies. So all the videos that I make, you're getting my unfiltered, unbiased opinion. So you guys have no preference on the location, whether it's zoomed out or zoomed in? Right before I started filming 3D printed construction sites, I was actually doing construction labor. I was doing some apprentice carpentry, and then when the world shut down, the contractor I was working for, the job slowed down, so he had me and one other guy doing some demo work. We were ripping up 20,000 square feet of commercial tile, and they didn't even rent out any Sunbelt equipment. They gave us crowbars for lifting up each of these 2-foot by 2-foot tiles, 20,000 feet. I was doing that job for 3 weeks, saving up money. I was actually living at home with my parents back then before taking the leap of faith full-time, saved up a little money for my construction job after college, and took off, traveled to Texas, slept on a friend's couch for 3 months to film an icon project. And from there, I just kept bouncing around. I went over to Europe. The very first project I filmed while I was still in school was in China, but I wasn't doing it full-time back then. And since then, it evolved. I created the first course over a year ago, and I deleted it, updated the whole thing, redid it, added a physics section. We got a bunch of Automation Nation members paying $10 a month for virtual tours of 3D printed buildings, and a list of over 100 printer manufacturers, a list of over 65 printed homes. I try a lot of different business methods, but they're all independent and all ideally unbiased. And yeah, it's still early in the industry. I picture construction continuing to evolve for the next 10, 20, 30 years, and I hope to film the whole thing. So yeah, we'll figure it out. Ideally, I can continue being just supported by you guys, the audience, so that I can stay unbiased. I'd love to build out a team.
Just
It's
a little bit, Tim.
getting tough to cover all the different construction automation sites by myself. When I started, there were maybe 12 companies in the industry. Now there's over 350. So yeah, I'd love to grow Automate Construction into a brand that can ubiquitously cover construction innovation all around the world. We just got this new logo, Chip, and Chip is our automated construction robot. You guys can pick these t-shirts up at the Automate Construction store at automateconstruction.com or automate.construction. We've got a hoodie too. And the new logo is named Chip. Somebody in the LinkedIn comments came up with that clever idea.
It's about to get wet right here.
Yeah, some groups do spray the water automatically. All kinds of stuff are being automated one step at a time. You can imagine a robotic arm could automate a lot of these processes done by humans, but for now, they're still figuring everything out. So one step at a time.
Pump volume.
And we are minutes away from the cleaning process. They'll extrude all the leftover material in the hose. I'm super impressed with the way the emergent team's working together, handling the print. I mean, allowing a live print, really brave, bold. One of the most productive teams in 3D printed construction right now. This is their 7th home they're building in a very hard place to build. California should not be discounted. One of the hardest places, if not the hardest place in America to get permits.
You want to disconnect that right away?
Now we are in Reading, so it's not as difficult as, say,
You need help?
LA, but
Yeah, I'm going to come help you out and keep on testing. You know, put that in the layer. Keep the bottom right here. Don't change what color this is. Right. NASCAR kick through time, baby.
the blankets over the wall are actually burlap, and this helps to increase the humidity in the materials. And the longer it cures, the more time the water has to escape the material, the stronger it ends up. I don't know which company would start printing in Hawaii first. I mean, if you're willing to be it could be up to you if you're the first project there, but yeah, Hawaii has a big housing problem and a labor shortage, so I could definitely see this technology being implemented there.
I'll move to Hawaii.
Sean says he's down for Hawaii. Now they'll finish this last printing element, and I believe that's when they'll start the cleaning process. And you got Evan screwing in the Daytons to get the rebar attached into the slab. For this earthquake zone in California, that's a critical step. It's really cool to see all these organic curves and shapes. Nico North makes. Remember you from where, Nico? Are you the Greek Nico? If it's Greek Nico, of course I remember. Yeah, they got curves on the outside walls. You could see the 3 finished homes they have on this side after they start the cleaning process, when we get some downtime. If my phone still has battery, I'll show you. Oh, we got Nico. Yeah, I remember that. You sent me an email and I helped to answer a few questions. Always happy to answer quick questions over email when I can. For longer stuff, I have consulting available for teams that aren't printing yet.
No.
But if you just want help with a quick question over email, I'm always happy to do my best to answer those for free. Now they're going to extrude the leftover material from the hose.
X negative 1,000. Why negative 500?
The cleaning process involves purging all the leftover material from the hose, which is a pretty big hose, so they get a good amount of material. And now they're spinning the U-axis of the extruder head.
What's the table?
Raymond, you're wrong about that, actually. This is a 99% localized mix, so all the sand is local, all the cement is local, all the gravel is local. They have a 1% added solution from Cemex, which is not local. But other than that 1% additive, this batch plant mixture they have enables them to mix the material on site locally using sand, gravel, cement. It does include some extra labor because you are mixing the material on site. So you got somebody at a forklift, somebody kind of helping load the material in, and then someone at the computer. So 2 or 3 people at the batch plant mixer. But with automation, once you have data on the ambient temperatures and how to make adjustments to the mix, that could be automated. There are definitely structural columns for it afterwards. So right now you see Evan over here installing the Daytons, which are screwed into the slab. And after the print, they'll pour in concrete to those sections where the printed concrete will act like formwork for the poured concrete. And the poured concrete will form the structural integrity of the building. That's how the engineer gets permits, how the building supports the vertical load of the roof. And now we're over 2 hours into this live stream where Emergent 3D is printing their 7th house. Now they've got almost all of the material flushed out of the hose. It won't be long before they're printing again. For less experienced teams, this can be a stressful process, but these guys have done it enough times that they barely even have to speak to get it all filtered out. They're cleaning over there, cleaning over here, installing Daytons, and you got operators. Since the action stopped, we'll take this opportunity to walk through the completed projects and under construction homes. So this is what they had built previously, and each of these homes takes them 6 days, 3 days on each side, build about a third of each, and then they work on the other section. So they're able to get these nice finishes, and at the windows they have these beveled walls. Awesome level of detail. This is the same model that they've been printing time and time again. The crew members definitely enjoy the job. They say it's better than traditional construction. It's easier, it's less labor intensive, less sweaty work. They've even got some of the electrical going in before the print is done. We saw the electrician working actively while the house was under construction, and you get some other cool features in here. Like, for example, with cinder blocks, they would need cutouts for the inspection where the rebar gets tied into the slab, and that's what they have right here, a cutout for the inspector. And then there's the other 2 homes that they printed before. They've got the girders in for the roof already on this one. And again, it's all the same, but you can see their layer quality is improving. So this is the second home they did, a little bit better layer quality than the first. This is the third, and now they're working on the 4th on this site. They also did 3 before this, so they've got a ton of experience now. You can see on the first one they had a little too much curing agent, so you get that white color, but it's not a structural problem, and they're going to paint it anyway. They did say that if they get a nice enough layer quality on the 4th home, they'll actually leave it without painting it or stuccoing it so that you can see the raw finish. And yeah, it's really obvious to me that they're getting way better at printing, and the quality of their print is improving. This is a testament to their team, their experience, and just walking from the first one they did to this is the third now we're in, and then the fourth over here. The quality you can see drastically has improved. I've got 5% battery, so I'm going to lose you guys any minute now. We'll see if we can last long enough to get the print started back up again. Right now they're doing a little pause to install the Daytons, and they're also taking, the Daytons are the rebar that they're screwing into the slab right now. You can see there, 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 there. And this is where they're pouring in the vertical columns afterwards. They're also taking advantage of this pause to do a clean out of the system. This flush out will help any sediment that may have gotten stuck, and it'll just improve the flow. They're probably starting up again any minute now. It sounds like they're getting the material flowing. Over here, you got Tim putting in some of the magic mix, and that's that 1% of the solution we're talking about that they ship in. The rest of the mix is localized, which is really fantastic. In construction, you want as much local as possible. Anything that's not local needs to be shipped, and that's extra cost. It's one of the 3 loading points of this system. Maybe 4, I guess, if you want to include water. 5 if you include the accelerant at the extruder head. Here. Any minute now, they'll start the material running through the system again. But it's a race against time as my phone runs out of battery. The magic mix is proprietary, not off the shelf. But Cobot is not the only team that has a magic mix like this. A lot of teams have developed their own custom solutions. This is one of the few batch plant mixers I've seen working really efficiently on site. Diamond Age also has a really efficient batch plant mixer. I believe Icon is developing a batch plant mixer. Mudbots is developing a batch plant mixer. The printer is the exciting fun part, but automation is needed everywhere, and the mixing pump system is one of the most labor-intensive parts of the job site, so having that automated with a batch plant mixer is really beneficial. Yeah, I'll work on those extra batteries, Verity. You're right. I've got to get some kind of external battery pack. Keep the charge going all day. I got 3 cameras and they all need my phone. The 360 camera needs the phone, the drone needs the phone. Oh, Verity's been working on some batteries. That's cool. I love battery technology. America has some awesome subsidies coming in for batteries. You definitely need kind of a special pump. You want a lot more control than a regular concrete pump has. So you either want a variable flow drive or some type of cavity in the extrusion to make up for the inconsistent pumping pressure. So you want to smooth that out. Anytime you're working with computers, you want precision. It's hard to get precise materials, precise pumping. Usually in concrete, precision isn't the name of the game, but when it comes to printing, all of a sudden precision is introduced. Now you can hear they're starting to pump material in again, and this is how they load the material with a forklift, an off-road forklift. And there's some serious pressure in that hose to push hundreds of pounds of concrete through. It's a big, thick hose, and it's filled with concrete, no air pockets or anything. Now we got material starting to extrude from the system again, and they'll be able to start right back up from where they left off. Since not too much time has passed, they'll be able to continue the layer and end up with a monolithic structure. Really efficient cleaning process, startup process. No yelling, screaming, no tears. So you got a hopper over here for the cement, a hopper for the sand, a hopper for the gravel, and then a section for the additive. Then that all gets mixed together into like a slurry, and then there's a finalized mixing process. And before it goes into the hose, it goes through a rotor stator, and that rotor stator gets everything really homogeneously mixed. There's a rubber tube inside of the rotor stator that wears down and needs to be replaced over time. And that replaceable rotor stator is actually a pretty expensive part that goes unseen. Then this system may have an additional rotor stator above the extruder head underneath the blue mixing auger, but I'm not sure about that.